Alright guys, we are back for our second video lesson in physics, and this lecture is about forces. So in your packet, we are starting on page, there's no number, page 3, okay? So in between 2 and 4, looks like this. Got your target at the top, terms to know, and we're starting with force, okay? So we're talking about forces. All right, terms we're going to talk about: force, which we're going to use a capital F, net force, and this little sign here is the summation sign, so it means sum of all the forces, tension, friction, Newton, which is a unit, capital N, magnitude, vector, scalar, and resultant. So vector, scalar, and resultant, hopefully, and maybe magnitude, you've kind of got these words down. The ones over here we'll talk about more today. All right. We're going to focus on the beginning of that target 1. So we're going to say I can analyze situations where the net force is 0 and determine individual forces acting on an object. Okay, so that's what we're going to try and work on today. All right, force, capital F. So now we are in the packet on page 3, filling in the blanks. So force is a push or a pull. A force is needed to change an object's state of motion, okay? An object will not change its state of motion unless you have a net force there. State of motion, what do we mean by that? A state of motion is either at rest, okay? So if you're sitting still, if an object's sitting on the table that is at rest, that is a state of motion. Moving uniformly in a straight line path, okay? So if I am going along straight line, in order for me to slow down, stop, change directions, there has to be a force. Okay, a force is necessary to start something moving from rest. It's also necessary to increase speed, to make an object turn, or to cause an object to stop. Okay, so again, we're just changing that state of motion. A force is not necessary to keep an object moving. Okay, so hopefully you're filling in your packet. Remember, if I'm going too fast on these videos, the best part is you can always pause and fill in your blanks and then press play and pick up with me again. Forces are measured in the unit called newtons. So time is measured in seconds or minutes or hours or days. If there's a force, any push or pull, we're going to measure it in newtons. So I can say, I pushed the table with 12 newtons, okay? So that is the label, that is the unit we use. All right, let's talk about net force, okay? So net means the difference or the combination. So the net force is the combination of all forces acting on an object. Kind of like if you think about net profit of a business would be like how much money have you put in versus how much did you earn. The net profit is kind of what you're left over with. So the net force on an object is what we worry about most in physics. It's what changes the motion. The net force depends on the magnitudes and directions, so remember the vector language then, magnitudes and directions, of all forces acting on an object. Okay, magnitude is the size or amount with appropriate units. We're good at magnitude. All right, so let's check our understanding. What are the possible states of motion when the net force is 0? Okay, so if all the forces are combining to be 0 newtons, what are the possible states of motion? You could be at rest. Okay, so right now I'm sitting in a chair, gravity's pulling me down, the chair is supporting me back up, I'm not moving, but there are forces acting on me. Or if you're moving in a straight path at a constant speed, that's considered all the forces are balanced because you are not changing your state of motion. So if a car is traveling down the road at 60 miles per hour, constant speed in a straight line, the forces on that object are 0. All right, so this scaffold here, these two painters, okay, what do the forces, see all these arrows are representing forces, all these vectors, they must add up to what? Okay, so take a second and answer that question. What sign should we give the upward forces for their direction? So take a second and answer that one. What sign should we give the forces in the down direction? Okay. All right, let's talk a little bit more about net force, okay? The net force depends on the magnitudes and directions of all the applied forces. So we've talked about that already. Okay, so something we talked about before, but what if the forces act right and left? What signs should we give for both of those? If you remember from the video on Thursday night, we already talked about what we would say right was and left was. Okay, so here we've got a chart we're going to fill in. All right, so if you have 5 newtons to the right and 10 newtons to the right, these two forces, the net force is a total of 15 newtons to the right. All right, if we've got 10 newtons to the right and 5 newtons to the left, we gave that a negative. Okay, so that 10 to the right, negative 5 to the left, that's going to give us a positive 5 to the right, okay? We do that tail to tip like we did before, you'll end up with positive 5 newtons. Let me move myself over a little bit. Okay, so down here, if we have positive 5 and negative 5, what do you think is going to happen? Let's take a second and predict that one. You said 0 newtons, it would stay at rest. That is awesome. All right, so let's add some more complicated numbers in here. So a staging that weighs 300 newtons. So on its own, gravity's pulling it down with 300 newtons, is supporting 2 painters. One weighs 350 newtons and the other weighs 200 newtons. So these vectors here, pulling them down, we've got 350 and 200. The tension in the left rope, so right here, this tension force, because tension is any pull, that would be a force, is 500 newtons. Okay, so if I label all of those, so I've got the weight of the staging, just saying that acts in the middle. I've got the 350 newton guy here, the 200 newton guy here, a tension here. The question's going to be, what's the tension in this string over here? Okay, so what is the tension in the right rope? So let's move me around again. So the way we're going to make this work, we know the force is equal 0 because it's not moving. So we're going to have a positive 500. Why is 500 positive? Because it's up. Plus question mark, that would be this force right here, plus a negative 350, plus a negative 300, plus a negative 200, all those negative because they're pulling down, that has to equal 0, right? The sum of your forces, so sum meaning add up all your forces, has to equal 0. Okay, so what is the answer? I think we're going to find out. Actually, we're not. Okay, so put in right now what you think the answer is. Sorry about that. All right, let's keep working. So we have, again, all our forces summing up to 0. There are 2 different scenarios you have here. I'm going to move myself down here. How do they compare? You have stationary, okay? If 2 children push on a crate, they push in the same directions horizontally with a force of 150 newton, 180 newtons respectively, but the crate remains stationary. What is the net force acting on the crate, and how do you know? Well, it has to be 0 newtons, okay? If something's not moving, the forces have to equal 0 newtons. So if they're both pushing on it, how come it's not moving? What could be holding it in place? Most likely it's friction, okay? They can't overcome the force of friction acting on the crate. So the question is, what's the magnitude of that force of friction between the crate and the floor? Well, it would be, to balance these 2 out, right, it'd have to be negative the sum of these 2, because our total force is going to have to be a positive 150 plus a positive 150 plus the question mark. The question mark will be negative 330. All right, let's look at the other side of this. Constant speed, okay, if you're moving with constant speed. Sorry, my bad. You have two children pushing on a crate. They push it in the same direction horizontally with forces of 155 and 187 newtons. The crate slides at a constant speed. What is the net force acting on this crate, and how do you know? Well, we know it's 0 newtons. Why do we know? Because of that constant speed. If you get a problem that ever says constant speed, that means it has to be 0 newtons. So what is the force of friction between the crate and the floor? We can do it the same exact way we did before. If the total's 0 newtons, and we know that there's two positive forces, what's going to balance that out? It's going to have to be a negative force of negative 342. All right, we're going to check our understanding real quick, and then we're going to be done. Which of the following statements are true? An object at rest has a net force of 0. If a person is moving to the right, the net force cannot be 0. A net force of 0 is demonstrated by an object which is slowing to a stop. It would take a net force to keep an object in motion. If an object is moving with a constant speed in a circle, then the net force acting upon the object is 0. And then this one says, if an object is moving with a constant speed in a straight line, that's what's behind here, then the net force acting on the object is 0. So which of these are true? These two are true. An object at rest has a net force of 0. Okay, if it's sitting still, has to have a net force of 0. And if it's moving at a constant speed in a straight line, then the object is 0, or the net force is 0. Okay, if you're moving to the right, a net force cannot be 0. That's not true. You could be moving to the right at a constant speed. A net force of 0 is demonstrated when an object slowing down. If you're slowing to a stop, you're changing your state of motion, so that can't be 0. It would take a net force to keep an object in motion. It would not. If an object is moving with a constant speed in a circle, so circle changing directions, then it would be net force equals 0. It can't be if it's changing directions. All right. One more, check your understanding. Burrell and Paul have combined weights of 1,300 newtons, which push downward on a stationary scaffold. The tensions and the supporting ropes that support the scaffold they stand on add to 1,700 newtons. The downward force due to the weight of the scaffold itself must have a magnitude of what? Okay, so you've got a 1,300 newton force pushing down. You've got 1,700 pushing up. And they want to know what else is pushing down, okay? So if we work this out, we get 0, remember it's not moving, is equal to negative 1,300, that's the downward weight, plus 1,700, that's that tension force up, plus another positive force, right? Solve for it, we get negative 400 newtons. Wait, I said that was positive. I was wrong, okay? It's a downward force through the weight. So what we're looking for F is negative 400. But they only ask for the magnitude, so the answer is going to be just 400, okay? All right, one more. Try this one on your own. Pause the video and try this. Okay, the answer is positive 600 newtons. Good job, you guys are done.